Hello everyone, in this section we're going to be looking at solving other types of equations, some of them based on the quadratic model, some of them just based on techniques from there like factoring. So we'll just look at a handful of examples and they'll kind of be ad hoc, meaning, you'll just see different types of solutions presented for each one, and they require, techniques that come up in a variety of ways. So the first few will involve factoring, so let's go ahead and look at that. Example. We want to solve, so we'll say solve for x. And this first example will have 2. Let's say we have 5x cubed minus 10x squared equals 0. Well, in this one, basically what we have is we have a greatest common factor that we can take out. So the idea here is we want to factor out 5x squared and apply the zero product principle, meaning that if two things multiply to 0, then one of those factors must be 0. So if we factor out the 5x squared, we'll be left with x minus 2. So we have two things multiplied that make 0. So either 5x squared equals 0 or x minus 2 equals 0. So solving that, we can divide by 5, and then you end up with x squared equals 0. Well, that means x is plus or minus 0, which are the same thing. So x equals 0, or we have the other solution by adding 2 to both sides of the equation. We have x equals 2. And those are both of the solutions. So that's the first one. The second one will have a slightly trickier variable substitution, but it'll still be the same technique. So let's say we have the equation 3x plus 5 raised to the fourth power minus 3x plus 5 raised to the third power equals 0. Well, this one's similar, but now we're actually factoring out the common binomial that's in both parts. So we want to factor out the biggest power of that common binomial that we see, which is 3x plus 5 to the third. So we want to factor out 3x plus 5 to the third power. So if we do that, we get the 3x plus 5 to the third power, and then we'll be left with this 3x plus 5. There will be one factor of that left. And then we've taken out all of them, so that's all we have left is the minus 1. So we get 3x plus 5 minus 1. And of course, the 5 minus 1 can be simplified to just a plus 4. So we'll have 3x plus 5 cubed times 3x plus 4, which equals 0. And now one of these two factors has to be 0, so we apply the zero product. So we have either 3x plus 5 to the third equals 0, or 3x plus 4 equals 0. The only number that's cubed that makes 0 is, again, 3x plus 5 equals 0. And to solve this, we subtract 5 and divide by 3. So this gives x equals minus 5 over 3. That's one of the solutions. And the other solution, we want to subtract 4 and divide by 3. So we end up with x equals minus 4 over 3. So those are the two solutions to this problem. So moving on, let's look at some radical equations. So radical equations. In particular, we'll just be looking at ones that involve square roots, but the same technique will apply to cube roots and fourth roots and any finite root. So the technique here is isolate the radical on one side of the equation and then we want to raise both sides to the power that eliminates the radical. So if it's a square root, you square both sides. If it's a cube root, you raise both sides to the third power, and so on. And then we want to use general techniques to solve the resulting equation. And then the thing is, we need to, whenever we have a radical equation and you square both sides or something like that, it introduces the possibility of extraneous solution. So we always need to check our answers in the original equation. Okay, so let's look at some examples highlighting the way that we implement this strategy involving some actual values. So again, we just want to solve for x. So A, let's say we have, the square root of 8x plus x equals 0. So the first thing is to isolate the radical. So we will subtract x from both sides. So we end up with the square root of 8x equals minus x. And then you want to square both sides, which is going to get rid of that square root. And again, notice that minus x squared is just x squared. So we end up with 8x equals x squared. We can subtract our 8x. And then from there, we can factor to solve. So we end up with, again, two answers, but as we'll shortly see, only one of those answers will in fact work. So we can factor out the x. So we get x times x minus 8 equals 0. So we either have x equals 0 or x minus 8 equals 0. So that would be x equals positive 8. 8 minus 8 would give 0 in the second factor. So if we check those in our original equation, if you plug 0 in, the square root of 0 plus 0 does equal 0. But so let's check the second solution to show that in fact that does not work. So if we do the check, so the square root of 0 plus 0 equals 0, so 0 checks out. But if you do the square root of 8 times 8, which is 64, plus 8, this equals 16. So that does not check out, which means x equals 0 is your only solution. X equals 8 is known as an extraneous solution. So we only have one. So let's move on to another example, another radical equation. This one may be a little bit trickier. So we checked and we only had the one solution. Yeah, good. All right, so back, let's look at B. Now for this one, we have the square root of 2x plus 1 plus 1 equals x. So again, the strategy is to isolate the radical. So we begin this problem by subtracting 1. So now we have the square root of 2x plus 1 is equal to x minus 1. And this is where we square both sides. So we're squaring the square root and also squaring the quantity x minus 1. Remember, we're doing both because in that case we need to FOIL. So really, this side is going to come out to x squared minus 2x plus 1. Keep that in mind. X squared minus 1 is x minus 1 times x minus 1. So when you FOIL, that's why you get the x squared minus x plus 1, which is the x squared minus 2x plus 1. So that's where we get the simplification from the right-hand side. And now we want to move everything to one side because we're left with a quadratic. So we get the minus 2x minus 1. So now we have 0 equals x squared minus 4x, and the plus 1 and minus 1 cancel. So now we have a pretty simple quadratic where we can just factor out an x, and we get x times x minus 4. So we get two solutions here, x equals 0 or x equals 4. And again, we want to check them. So on the one hand, if you plug in 0, you'll get the square root of 1 plus 1, which does not equal 0. So let's just check both of them quickly in that original equation. So the check here, the square root of 2x is just going to be 0, so we get the square root of 1 plus 1, and the value of x is 0, so that does not equal 0. So that does not check. And if you do the other one, where we have our second answer 4, we would be getting the square root of 8 plus 1 plus 1, and that in fact is equal to the square root of 9 plus 1, which is 4. So our second solution checks. So in this case, the x equals 0 is extraneous, and 4 is our only solution. So this one is extraneous as well. So that is our second radical equation. Okay, so let's move on to the last type, where we have equations of the quadratic type using a variable substitution. So equations of the quadratic type. So that's the key here. We want to, they look almost quadratic, but we need to substitute a variable. So substitute to transform to a quadratic, maybe in some other letter. Okay, so looking at these, we have first, again, I'll just say solve for x. So the first one we have, let's say A, we have x minus 3 quantity squared minus 7 times quantity x minus 3 plus 12 equals 0. So to solve this one, let's let y equal the parenthetical quantity x minus 3. If we do that, this becomes a quadratic equation. So it just becomes the equation y squared minus 7y plus 12 equals 0. Then this is one of our quadratic equations that factors into two binomials. We just need two numbers that multiply to positive 12, but add to negative 7. So we get y minus 3 times y minus 4 equals 0. So y equals 3 or y equals 4. But remember, we're not exactly trying to solve for y. We just use that variable substitution as an intermediate step. So we want to plug back in. Remember, y was really x minus 3. So x minus 3 equals 3, or x minus 3 equals 4. And then you just add 3 to these equations. So we get x equals 6, one of our two solutions. Or adding 3 to the second equation, we get x equals 7. So those are our two answers for that problem. The second one here, let's say we have 2x to the excuse me, 6th power minus 3x cubed minus 9 equals 0. Now, this is still a variable substitution, but it might not be as obvious to you. But once you get the hang of it, you might recognize that. Basically, for this one, we want to let y equal x cubed, because if you square both sides, that would mean that y squared is x to the 6th. So the 2x to the 6th becomes 2y squared, and the minus 3x cubed becomes minus 3y. Minus 9 equals 0, and we again have a quadratic equation. This one factors as well. Remember, the coefficient in front is not 2, so we have to use the longer method. So we factor by grouping. 2 times negative 9 is negative 18. We're looking for two numbers that add to negative 3 and multiply to negative 18, so those would be minus 6 and plus 3. So we get 2y squared minus 6y plus 3y minus 9. equals 0. We're splitting that middle term because minus 3y is the same as negative 6y plus 3y, which are the numbers that we got to start. And then we factor the GCF of the first two, which is 2y, and we get y minus 3. And then we can factor 3 from the second group, and we get y minus 3. And then we get our factorization, 2y plus 3 times y minus 3 equals 0. And we have our two answers in terms of y, 2y plus 3 equals 0, or y minus 3 equals 0. And then solving the linear equations, we have y equals negative 3 halves, and the second one gives y equals 3. But again, remember, we're not trying to solve for y, we're trying to solve for x. Picking y there was just an intermediate step, so what was y originally equal to? Y was equal to x cubed, I believe. Yeah, so x cubed equals negative 3 over 2, or x cubed equals 3. So we get our two solutions here by taking the cube root of each side. So x will equal the cube root of negative 3 over 2. Since it's a cube root, we can actually pull the negative in front, or x will equal the cube root of 3. So those are our two answers, and that's it. So when you have things that look quadratic, you can oftentimes make a variable substitution to reduce it to a quadratic, and then just remember to plug that variable substitution back in at the final step to solve for your original variable. So that's it for these other types of equations. We looked at three different types: factoring larger degree polynomials, looking at radical equations, and then reducing equations of the quadratic type using variable substitution. So this is Dr. London signing off.